In this video, we're going to take a look at some examples using the fundamental theorem of calculus part 1. So the first example we're going to do is we're going to use the fundamental theorem of calculus part 1 to find dy dx, so the derivative of y, when y is equal to this, which is our integral function from a to x of t cubed plus 1 dt. So what does this mean? Dy dx is equal to the derivative with respect to x of this function right here, this y, which is the integral from a to x of t cubed plus 1 dt. But what does our fundamental theorem of calculus part 1 say? Well, it says that the derivative of this integral function is just the inside function, but with respect to the variable x now. So this is just x cubed plus 1. And that's it. That's all there is to it for that kind of a problem. Let's do a slightly more complicated version. And let's let now y equal to the integral from x to 5 of 3t sine of t dt. Now here we want dy dx to equal the derivative with respect to x of this integral. But here is our problem. This does not fit what our fundamental theorem of calculus part 1 says. Here we go from x to some constant. What the fundamental theorem of calculus part 1 says is we go from some a up to some constant a up to the variable x. So if we switch this order of integration, then we will put our function into the correct way that we need it. But if we switch this order of integration, that means we take the negative of the integral. So this is the negative of the integral from 5 to x of 3t sine of t dt. All right, this sets us up really well now. This now looks almost exactly like our fundamental theorem of calculus part 1. First thing we're going to do though is we're going to pull out the negative. So this is just the negative of the derivative of the integral from 5 to x, 3t sine of t dt. And now this looks like our fundamental theorem of calculus part 1. And so this is just negative of the derivative of this thing, which is just 3x sine of x. And so we have successfully calculated the derivative of y here. All right, we have one more example to do in this video. And that is, suppose y is equal to the integral from 1 to x squared of cosine of t dt. Now here's the issue. We have an x squared up here. We need that to just be a single x or a single of some other variable. So the problem here is the upper limit of integration is not x. So we make a change of variables. And that change of variables is the change u is equal to x squared. And so what does that mean? That means this becomes y is equal to the integral from 1 to u of cosine of t dt. And now this looks closer to the form that we can use our fundamental theorem of calculus part 1. So write this down, and then what we're going to do now is we may now apply the chain rule. All right, let's take our derivative of y with respect to x. Y is now a function of u, though, and then u is a function of x. So by our chain rule, this derivative is dy du times du dx. All right, it's supposed to be a u there. Sorry about that. Which means we are taking the derivative with respect to u of y, which was the integral from 1 to u of cosine of t dt. And then we need to multiply this by du dx. All right. What is the derivative of this integral? Well, that is just cosine of u, right? Cosine of, and then the variable that's up here that we're going to. And then we multiply by du dx. So that is 2x, because u was x squared. So the derivative of that is 2x. All right. But we don't want our function in terms of this variable u that we created. We want it back in terms of x. Since u was x squared, this is really 2x times cosine of x squared. And that is our derivative. And that's where we'll end this video.